Alright, these are your notes for section 12.1 on nets. Now, what we're going to do in this section, it requires you to think about a three-dimensional object and break it down and pull it apart and make it into a 2D figure. And that's what a net is. So we're going to go over some vocabulary first. We're going to talk about what a three-dimensional figure is. Okay, a 3D or a three-dimensional figure has three things. It's got length, width, and height. And this is why it's three dimensions, because there are three of these things. A two-dimensional figure will only have length and width. It'll only have two of those things, and you can interchange height in there if you would like. It just depends on how you want to think about the problem, but it only has two of those three. A three-dimensional figure has three of them. Okay? So right here, if we look, we have a rectangle, and that's a two-dimensional figure because it has, we're going to use width, that's how wide it is, and we're going to use height, that's how tall it is. It's got two of the three dimensions that we listed. Now, if we extend it back a little bit, connect our ends, and we add length to it, now it's a three-dimensional figure. Okay, it's got height, how tall it is, it's got width, how wide it is, and length, how long it is. And now, length and width can be interchangeable. Height is always how tall it is, but length and width, they can go back and forth. It doesn't really matter where your L and your, if you want to make the length how far across it is and the width how far back it goes, that's fine too. It doesn't matter. Those get used interchangeably. But what I want you to see is that this has three dimensions. Okay? Now, a net is a two-dimensional representation of a three-dimensional figure. Okay? So what we want to do is we want to pull this figure apart so now that it all lays flat and it's two-dimensional. It's all made out of two-dimensional shapes. So we're going to draw a net for our figure above here. Now I'm going to tell you what this is called. This is a rectangular prism. Okay, so we're going to draw a net for this rectangular prism. What we want to do, I'm going to add a little bit to our figure here just so that we can see that there are 6 sides. There's a front and a back, a top and a bottom, and a left and a right. We're going to start with the one that it's sitting on, which is a long rectangle. Okay? And then I'm going to, let me redraw it for you and we'll mark out what we've already drawn. Alright, we started with this, the bottom. Okay? That's what we've already drawn. Now let's do this side here. So we would add another rectangle. And then the other side. So right now we have the bottom, the right side, and the left side. Now we're going to add one more for the top. And notice that all of these are connected. If I folded them back up so that my bottom was still sitting on the bottom, they'd all meet and make the longer rectangles of our rectangular prism. Now we also have a rectangle in the front and a rectangle in the back. So here's our front, and this is the back. And that's a net. That's what we would draw to represent this figure. Now I will tell you that there's more than one net for a lot of figures. This isn't the only thing you could draw. You could have drawn something like this. It's very similar, and I'm drawing it smaller, but put an end here and an end here. If I fold that up, it's still going to give me the same shape. It's still going to give me the rectangular prism. Okay, so there are more than one net for a three-dimensional figure. What we're going to do here now is we're going to draw a net for each one of these figures. We have a triangular prism and a cube. And notice that they gave us numbers, which means we're going to have to label the sides with these numbers. So let's start with this triangular prism. I'm going to add some 5s to this. Okay? If this back here is 5, that means the top and the right-hand side, where how far back it goes, the length that I have marked, those should be the same. So it should be 5 for all of them. And then this is 3, and this is 4. Okay, so this 5 goes to that, how long it is. So let's start with the bottom. We're going to start with the bottom again. We have a rectangle. That rectangle is 3 and 5. Okay? Now let's draw the rectangle that's facing the right, kind of the upper right-hand side. It's a bigger rectangle. And this is 5 again. Notice we don't have anything here. It's not given in our picture, so we're just going to leave it blank. Now we're going to go to the left, another rectangle. This rectangle is 5 and 4. Okay? So far we have the big rectangles already drawn. We don't have the two triangles on the end, the front and the back. So let's do that now. Draw this one here. Now notice if I fold this together, these two sides should meet, which means that this one has to be a 4. And the same thing as we draw the back. This one needs to be a 4 also, because if we fold these together, they're going to meet. And they would be the net for our figure. Okay? Next one, we have a cube. Same idea. Let's start with what we're sitting on. And the side is marked as a 2. Now, for a cube, all of the sides are the same, so we only need to mark it once, and everything's going to be the same. But we've got the front. We're going to do the right-hand side, and the left-hand side, and then the top. So we have the bottom, right, left, top. Now we need the back and the front. And there would be the net. Notice it looks a lot like our rectangular prism that we drew earlier. It's just different shapes, two-dimensional shapes for the sides. They're different. Okay? Next thing we're going to talk about is what is surface area. Surface area is the area of all the faces, or you can think of them as the sides of a 3D figure. Okay, another way of thinking about that is the area of the net we draw. Okay? What we're going to do is we're going to draw a net, and I'm going to pick the shape. I'll give you the shape here in a second. Draw a net for the shape I give you, and then we're going to give the surface area for it. Okay? So let's draw triangle. We'll do 3 and 3. Okay, we've got a triangular prism here, and we'll make this 4. Okay, we're going to draw a net for this first. So we start with the bottom. We have a rectangle. And 3 and 4 for our bottom. Now we need to draw the right hand, the side that faces the top right. And then we need to draw the left hand side. And it's 3 also, so these are 4. We don't know what this is. Okay, that's this side right here. We can figure that out, though, by using the Pythagorean theorem. So 3 squared plus 3 squared equals c squared. 3 squared is 9, plus 9 equals c squared. So we've got the square root of what ends up being the square root of 18, and we can put that in our calculator. We'll round it to the 10th place. The square root of 18 ends up being 4.2. Okay, so that's how long the hypotenuse of the triangle is, 4.2. Now we need to do the back and the front. So here's the back and the front. Remember, these two sides are going to get folded together, so that needs to be a 3. Same thing here. These are both 3s because they're going to get folded together. Okay, so there's the net. Now the surface area, we're going to add all of the shapes together. Well, 4 times 3 is 12. That's this one. The middle one, 4 times 3 again, another 12. This one over here is 4 times 4.2. It is different. So 4.2 times 4 ends up being 16.8. And then the front and the back, they're both triangles. Remember your formula for a triangle, 1/2 BH. Well, our base is 3 and our height is 3. 3 times 3 is 9, times 1/2 would be 4.5. And there's a front and a back. Okay, notice I had 5 shapes drawn. I have 5 numbers here that I'm going to add together. I'm going to put in my calculator. 12 plus 12 plus 16.8 plus 4.5 plus 4.5. We end up getting 49.8. We need to give it a label. Units, talking about area, so units squared. Okay? So that's how we find surface area. That's what surface area is. It's the area of all the figures on the outside of the shape, or we can think of it as the area of the net that we draw. Now, the next question we've got here is, what is volume? Volume is the space inside a 3D object. Okay? So if I were going to fill it with something, fill it with water, or fill it with sand, fill a 3D figure with either of those, I want to know how much stuff is going to fill it. And that's what volume is. Okay? And volume is represented in units cubed. The reason it's in units cubed is because there are 3 dimensions for a 3-dimensional object. You remember you have length, width, and height. Okay? That's where we get the units cubed from. Alright? Now, for each figure that we will learn, they all have different formulas for volume. So you're going to have to memorize the formulas for volume for each 3-dimensional figure, and really all you're going to do is just plug numbers in and solve it from there. Okay? Just make sure you have the correct label. Let's recap here. A net is a 2-dimensional, like blueprint or drawing of a 3-dimensional figure. 3-dimensional figures have length, width, and height. Surface area is the area of a net, or all of the faces of a 3-dimensional figure added together. And volume is the space inside of a 3-dimensional figure. How much can you fill it with? If you have questions, go back and rewatch the video and see if it clears anything up, whatever specific part you need to watch. If you still have questions, bring them to class next time.